Hello. So if you probably actually want to go to Pat's talk, which is downstairs, the C word, would highly recommend it. It's a good friend of mine. So if you can't hear, would definitely recommend going downstairs. I was talking to Emma, who's from Melbourne, and she was telling me I was helping out with the Rails Girls thing yesterday, and I was trying to get Wi-Fi, and she told me that you all like read things upside down, so I decided to do my presentation upside down. Man, this thing is really sensitive. So I'm Terrence. I'm the guy who wears the blue hat. So if you've seen presentations of me before, I'm usually walking around in blue hat, or at the conferences, that's how people find me. I go by Hone02 on Twitter, or you can find me as Hone on GitHub, or Terrence at Heroku.com. Feel free to reach out to me with regards to anything Ruby, Bundler, RouterGate, anything. I live in Austin, Texas. I haven't been home since November. But Austin's a great place for tacos, so if you're ever in town, feel free to hit me up and I will take you out to tacos. I think we have some of the best tacos in the world. We also have this really awesome barbecue place called Rudy's. And the best part about Rudy's is we have these like awesome washing machines, and you just like stick your hands in these machines and like wash your hands after eating a bunch of greasy meat. And then you get one of these awesome stickers that goes with it. I have clean hands. So if you ever see Constantine's laptop, this is probably the best sticker on his laptop. So I think like for my next set of presentations, and go like take a bunch of these when I go home and like hand them out instead of Heroku stickers. And then I work on a few community things, like the same Bundler API, which I'll be talking about today, Rescue, and then helping out a bunch with the Rails Girls. I was at the Rails Girls thing yesterday. If you guys have never been a part of something like Rails Girls or Rails Bridge or any of these teaching workshops to beginners, I would highly recommend it. It's definitely a great way to really be able to see what it's like to be a beginner again and realize how hard it is and how much stuff we take for granted, and really gives you a fresh perspective of all the things you do know and like helping people. Definitely highly recommend it if you've never done it before. And so based off of Corey's keynote this morning, I as well take a lot of inspiration from Aaron, but for different things. So one of the things that I really love about Aaron is he started this thing called Friday Hugs. What? That's not what I want. So if you guys aren't familiar, every Friday he would take a picture of himself, I guess like hugging a web camera like this, and sometimes his cat would participate. By the way, his cat's name is Gorbachev Puff Puff Thunderhorse, which is a really awesome cat name. So based off of all this, like I went around the world a little bit talking, and I decided to do some Friday hugs myself. So, wait, wrong way. So I went to Frozen Rails in Finland. We did one. This was in Singapore. This was in Amsterdam this last year. This was in Lyon, France at Ruby Lugnum, and then Cascadia Ruby as well in Seattle. And I have some other ones that I haven't posted. So my title is a Friday Hug Evangelist now. So I know today isn't Friday, and I was talking to the speakers, or to the organizers, and they wouldn't give me a slot on Friday. So we decided that we're going to do a warm-up Friday hug before the Friday hug for the keynote. So Richard, my lovely coworker, is going to come and take a picture. Yes, lovely.
Thursday hug, everybody.
Thursday hug.
Stand, or yeah, go like this. I won't be able to get all of you. Jesus. All right.
Go back another 10. Yeah, just got to go backwards a little bit more.
Okay. Man, why are there so many of you? Okay, everybody say Friday hug.
Friday hug.
All right.
Thanks, guys. Yeah, so senior Ruby engineer, Heroku, we talked about that. So on to the actual talk. So the agenda is I'm going to talk a little bit about Bundler. I don't know if there's new people in this room who haven't used it before, but we're going to talk about Bundler and how it interacts with the API. Then we're going to talk about rubygems.org a little bit, and then the Bundler API service that came out of it, and then depending on how much time we have, there's a bonus round where I'm going to talk about some other prototype stuff that we've been working on for the Bundler API. So on to Bundler. I guess show of hands, how many people have never heard of Bundler or used it before? Thanks, Aaron. I think you have commits to Bundler, bro. So just real quickly, Bundler is a dependency manager for Ruby. You have something like this gem file, and you list all your gem sources. Usually it's just rubygems, but if you have private gems, you might list those as well. Private gem servers, maybe like gem sources from GitHub, and then you list all your gems. The main interface here is just bundle install, and it'll go through and fetch all of your dependencies. And then it does the whole resolution and resolve there, so you don't have to figure out all the actual gems you needed. I don't know if you guys remember from the before Rails 3 days, but it was a huge pain in the ass. I remember having to, when I started at my first like Ruby job full time, it took a whole day just to get the app working, and you would have like the list of gems in some README, hopefully, and you would manually gem install them, or if you're lucky in your Rails 2 project, you had all the config gem lines, and some of the gems weren't actually listed that you needed because they had to be installed manually, like if you're using Cucumber, and then hopefully your coworkers would tell you the exact version of Cucumber you needed because Cucumber wasn't very backwards compatible back in the day. And so yeah, it would be a whole like whack-a-mole of trying to get everything working. So I'm super happy that Carl and Yehuda got Bundler into Rails 3. So just doing a standard bundle install, we get the awesome fetching source index from rubygems.org, and then it would take a really long time. And then, so just for that single gem file of Sinatra, it would take about 18 seconds from America, where the servers are located. So kind of pretty slow. So probably wondering like, why is this really slow? Like, why isn't it faster? What is wrong with Bundler? And in order to sort of understand like a lot of this, you have to look at a little bit of how Bundler actually does its dependency resolution. So Bundler has an index which contains all the specs and metadata information it needs to actually do the resolve. So we have this index. We have this index class, and you have specs that, so this instance variable specs is a hash that is keyed by the gem, and then the value is, I believe, like where you download it. And then you go through, and we go and fetch all these remote specs. And looking at fetch all remote specs, we actually call from rubygems the spec fetcher. And you actually have to call it twice because there's a bug. There was a bug in older versions of rubygems where if you listed true, the first thing is trues for the normal gems, and then the second one is I want to also fetch the pre-release specs. But if you did true, it wouldn't actually return the whole set list. So you have to do two independent calls here. And so looking at that, we get these modern indexes. So specs.48.gz and pre-release specs.48gz. And given those two things, you can get the whole set of all the gems that have ever existed on rubygems. And so a lot of people back in the day when they were complaining about Bundler thought, oh, it's just like because the index is really large, it takes a long time to download everything. But as you can see, I did this like a week ago when I made these slides. And the modern index, so not including the pre-release specs, is only 1.2 megabytes. And so rubygems is on CloudFront using S3, and you probably have a CDN that's reasonably close. But even if you don't, like, it probably doesn't take very long to download 1.2 megabytes, not 18 seconds worth. So clearly there's a slowdown somewhere else. So if we actually look at what what is actually contained in this. It's actually just a gzipped Marshall of this array. So if we decompress it and load it inside a Marshall, we see that it's an array of this tuple set of the gem version, and the platform it's running on. So for most gems, that's Ruby, but you have Java for JRuby, as well as I think like MS Sigwin stuff. There's like a few of them for Windows, or Darwin for OS X, if you have those platform-specific gems. And given all that, we can build these remote specification objects that we use for the resolve. So we don't actually have all the information. We just have the tuple that was handed back to us. So all it contains is the name, version, and platform, and then a way to download more information if we need it. So one of the things that we notice is that it actually has no dependency information whatsoever. So like, given Sinatra, we actually have no idea what its dependencies are. So you can't actually do the resolve with just the stuff from the index. So rubygems has the gem spec files for each of the gems that are pushed to rubygems. And you have this gem spec RZ file that you can download. And inside of this, we actually get the dependency information. So if we go through the same exercise, we call spec.dependencies, we see now we get the dependency information that is now part of Sinatra. So going back, if we fetch all remote specs, as we saw before, gets all the index specs, and we need to go through and create all these remote specifications, and then fill this this hash of the stuff we need, and then we have the complete index of all the things potentially that we might ever hit to do the resolve for your app. But as you can imagine, that's like really slow because you have to load. You essentially have to create all these objects inside of Ruby for every single gem version and platform that has ever existed. And over time, this gets slower and slower because people are pushing more gems, not taking more gems down from rubygems. So when Bundler first came out on a Lino 256 megabyte VPS box, Bundler would run out of memory because it would take too much memory to do the resolve on just the modern index, because loading all this stuff was taking too much memory. So when I joined the team, one of the things that we realized was this can't go on forever, and we needed to come up with something that would be better. So this is what probably the major feature of Bundler 1.1 that most people noticed was we started hitting this API endpoint and integrated that into Bundler. So if we do the same gem file in Bundler 1.2, we see that it only takes 3 seconds versus 18. So a pretty significant speed improvement there. And so what this does is it actually hits this API endpoint on rubygems, API v1 dependencies, and then you can pass this gems parameter on. There we go. This gems parameter and it's just a comma separated value list. So you can do Sinatra, comma, rack, comma, rspec, or whatever that's in your gem file, and it will return the top level dependencies that it needs back. Yes. It returns I think it returns the version numbers as well, and then. Oh no, you can't provide version numbers. You just specify the gem name, and it returns everything back. The reason we don't do version numbers is because potentially you might need more information than just the stuff for that specific version. So this is if we call that URL using open and then do Marshall load, we get this information back. So so similar to the index, you get the name, number, the platform, and then now we get the dependency information. So given all that, we can actually write a recursive method that goes through and, given like a gem file, you have a starting list of dependencies, and even though you're only given the top level stuff back, you can imagine you just can iterate through until you run out of dependencies that you don't need anymore. So when you have the empty set of dependencies of stuff you don't need to fetch anymore, you're done, and then you can return that whole list back. And then we also, so instead of creating these remote specifications, we can actually create these endpoint specifications that now take the dependency information. Given that to the index, we now don't have to fetch all the gem spec RZs potentially and keep that whole graph in memory. We can now constrain it to only the gems of interest that return back from the API. So like going quickly through our sample, we have, if you get the debug information, you can see the query list that's being printed. So we first pass Sinatra, and Sinatra, some versions of Sinatra have these dependencies. At least one version of them have tilt, rack protection, rack, and mongrel. And then the next level returns these, and then you're down to rake, and then eventually you get an empty query list. And so given that, we can now constrain a bunch of the CPU work we had to do of creating all these things in memory. So this was great, and it was actually really successful. Bundler 1.1 was probably a really happy day for a lot of Rubyists when that launched. I remember getting just a lot of really positive tweets about it. So now let's take a look at sort of the server side now on rubygems.org. So in order to understand the sort of situation, if you look at rubygems.org and the sort of current infrastructure that it was on, you can see that in the old setup, it was using a single box, and it ran everything on that one machine. So it was running the Rails app server. So if you go to github.com/rubygems/rubygems.org, you can actually see the open source Rails app. And it's actually a great project to get involved with if you're new. There's a lot of really helpful people, and they're really active, and it's a modern Rails app. So definitely recommend checking it out and helping out there if you want, or if you're looking for a project to help out on. But you know, it's running that Rails app, and then there's also the Postgres database that it connects to, where it stores a lot of the meta information, like the user account stuff when you log in. And then there's also the Redis database that's using for stats and other things. And the dependency information actually lives inside of Redis. It's in Postgres as well, but the API at the time was using Redis for speed purposes. And on October 17th of last year, RubyGems went down really hard. And we did a post-mortem at that time, and we found out that Bundler API was consuming 70 to 80% of the traffic going to that machine. And one of the huge reasons why was because Bundler 1.1 was defaulting to using it, and a lot of people ran bundle install for basically like every single Rails app that was on Rails 3 and above. And it also took, so it was a 4-core machine, and it took 380% of the CPU out of a total of 400% just running Ruby. And a lot of that was due to the marshalling. So Bundler can't have any dependencies because it's a dependency resolver. So you want it to not have any of its own dependencies. And if we do have any, we vendor them in. So we vendor netHT persistent, and that's about it. And Thor for the CLI stuff. But so we chose to use marshalling for the data format that is returned to Bundler from the API to get that information back. And Marshall can be CPU intensive for large sets of data if this is all you're doing, right? So they disabled the Bundler API that day and brought rubygems.org back, so we could at least have a site that you could go search for gems, push gems to, etc. But like us on Bundler Core weren't really happy about that, especially like at Heroku, it was negatively affecting deploy times. And as a whole, like the community, I don't think was pretty happy about this. So one of the things that we proposed was creating extracting that API out of RubyGems and running it as a separate service. If we're CPU constrained, we can run it on an external service that rubygems.org just redirects traffic to. And so we built a prototype and had something running on Friday, so on the 19th. And then a week after the incident, we had it running in production. So we got it back up and running pretty quickly after. And what's interesting about this is it's the first time where a major piece of RubyGems infrastructure has been extracted outside of, I guess, like their server setup. So hopefully paving way to a federated RubyGems. So potentially other people can do interesting things with the data and not sort of be constrained to having that on rubygems.org itself. And so the application architecture for this is we had an API endpoints. And since this is a separate service, we didn't have access to any of the databases or data stores that was on RubyGems. So we had to keep our own set of the metadata information to return the API stuff up to date on our own. So initially, to get this up and running, we wanted to do the minimum amount of, we wanted to have the minimum amount of work for the rubygems.org team to get it running. So we opted to have this polling code that would sync. And so basically, it would pull from the indexes that you would get from Bundler 1.0 that is on RubyGems, and then populate the database and find the diff of gems that are new and gems that are removed. And then hopefully, and then eventually we move towards, this isn't totally complete yet, but a webhooks method, the webhooks way, where when you push a gem to RubyGems, it actually notifies Bundler API so we can update our databases. So we don't have to essentially go through the whole index every time someone pushes something. So the API endpoints, so we started with a dump from the rubygems.org Postgres database. And since the data set of rubygems.org, I think it's around 50,000 gems and, well, gem version platform tuples that exist. It just broke over 50,000 recently, so not a really large data set. We figured we could stick with the Postgres stuff and we didn't have to use Redis. And so we got a dump of the Postgres database, and there's really just 3 tables here. And the important stuff is, so in RubyGems, you just have the name of the RubyGem itself. And then in versions, you have a foreign key to that RubyGem, and then the version number and the platform and whether this gem itself is a pre-release. And then also contains like description and authors and all that other metadata as well. And then you also have the dependency information. So this is essentially inside your gem spec when you specify that Sinatra depends on rack greater than 1.36. That greater than 1.36 is the requirement string, and then you depend on version, and version in this case would be the actual gem, so like Sinatra 1.0, and then RubyGem ID would be rack in that case. So given these tables, we had enough information to pull the information we need for the API. So after, I think this took us like half a day to reconstruct this SQL query that returned the right information that we needed that matched what RubyGems was doing with Redis. And I guess the only really interesting thing is you want to make sure to scope it to runtime. So there was a bug way back when we initially when RubyGems initially implemented it that was returning both the development and runtime dependencies. And if you do that, you run to major like cyclic dependency issues, because a lot of gems depend, like if you're developing, I think, other gems, like they depend on some gems of some versions, and then you get into this cyclic dependency where a gem A depends on B, and then B depends on C, but C depends on A, and you never can actually do the resolve. So we have to make sure to scope it to only the runtime stuff, because you don't actually care about development stuff when running in production when you're deploying your application. And so we just built this really simple Sinatra app, and it's a pretty standard CRUD app here. So you have API v1 dependencies, which matches what is on rubygems.org, and then it essentially just does a Marshall dump of this get deps call, which we get the list of gems into an array, and then we essentially make that SQL call and then have to massage it in that format that we see from before, and then return it. So, I mean, pretty standard, simple stuff. I'm sure all of you guys have built something similar to this. And then, so the hard part for a lot of this was getting the sync code right. And so, like getting the polling thing. So when we initially built the sync code, it would take I think, 16 minutes to just go through it once. And having a 16-minute delay every time you push a gem and whether it be available when you did a bundle install was pretty atrocious. And so the only thing it had to do was add new gems into our local cache and then yank gems that mark gems that are yanked so they don't get returned by the API. And so essentially we had a really simple threaded consumer poll, and you just go through every single gem and you go through all the specs in the index, and then you enqueue it in this poll, and then you shut the poll down when it's done. So you insert both a job which adds the gem and then a yank job which removes it. And so if we quickly look at the consumer poll, it's pretty standard. So we use queue from standard libraries thread, and it's just a threaded queue. And essentially what we can do is we can just enqueue jobs onto this, and then when we start the poll, we want to create a thread for how big we want the poll to be. So you can say I want like 10 threads, so it would create 10 threads of workers to run through it. And then join, just make sure to wait until all the threads are finished executing. And then we have, Aaron actually taught me this concept of this poison pill. And so what this is when you're done processing, or when you're done enqueuing all the jobs you ever want to use, you have these poison objects on the queue, and then when the worker loop, which is in this create thread here, sees a poison object, you know to break the loop and sort of exit the thread. So just enqueue enough poison objects to match the number of workers that you're using. So that was this is essentially the worker queue that we're using in the polling code. And so other stuff we did to improve response time was to, if the index hasn't changed, to use the 304 if modified since header, and then just make sure to go to sleep and check it again in like another minute, and not have to rerun through it because we know nothing has changed. So this allowed us to keep it down to like around a minute, and then we also cached all the local data into memory, so we didn't have to hit the database every time. So I think when it was running hot and we weren't starting it from cold, it would only take like 1 to 2 minutes. So a potentially 2 to 3 minute lag time was simply better than 16 minutes. But that's obviously not as good as webhooks if you can push data and then get it immediately. So on the rubygems side, we implemented this. So rubygems has webhooks. I don't know if many of you guys have used it before, but you can actually register webhooks on rubygems.org. When a gem gets pushed, you can get notified, and it can hit some endpoint of yours. You can specify to get notified for all gems or specific gems, like if you're depending on a specific version, or if you're depending on a specific gem and you want to get notified and you want action to happen, you can register webhooks with rubygems.org. So we got a special webhook that got inserted into rubygems.org that would notify for every single gem that got pushed, and would be part of the push process when you push a new gem. And it would essentially just send this payload of the information we needed inside of to the API so we could insert that into our database. And we have timeouts here because if for some reason the API is down, we don't want it to stop people from pushing gems. And then we'll just get that through the poll later on. And then you just need some authentication token to make sure people can't push like not true data to the API endpoint and pollute our cache. And then on the API side, so on Bundler API, it's pretty simple. You just have a post method, and then we essentially can just use the job that we use in the syncing code right here, and we have all the information that was passed to it. So all this code is up on RubyGems on Bundler-API, and if anyone wants to take a look at it or help out, like definitely looking for people. And so it's not just building this thing. We also have to maintain and run this service for all of you guys in the community that are using it and depending on it. So we're running this on Heroku. So Heroku has kindly sponsored to run the API endpoint for the community at no cost to RubyGem or to Ruby Central. So right now it's running on, just to give you a sense of like what we're using for resources, like 6 dynos running Unicorn. We have a master database Ronin for all the writes, and then we also have a separate read database for the actual like endpoint queries on a separate faller, the ICA. And so for those not familiar, the Ronin database only has like a 1.5 gigabyte cache and a single CPU, and I think the ICA has, I think, 2 or 3 CPUs as well, so just a lot more workhorse available, and then a 7.5 gigabyte cache that you can populate to maximize efficiency. So if at any point you start hitting disk for stuff on EC2, you get really terrible performance. So having a large cache there is really helpful. And the other thing we do is we actually use PagerDuty, which is a paging service, and we are actually on call for it. So if the API goes down or there are errors, we get paged. And so Andre, who's another person on Bundler, is on call, and then Larry, and then myself, and essentially we're on call all the time for it. And it kind of sucks, but hopefully it doesn't go down very often. And then another thing we do, so if you're here for Richard Talk, we use Papertrail, which we use for archiving events, and we also use it for notifying PagerDuty when there are problems. So we have various search queries that we get from the Heroku logs, and for any platform errors, it pages PagerDuty, and then we get notified about it, and we look into it. And we also use this awesome service called Librato for graphing our data. So this is a screenshot of, I guess, like the first kind of 6 dashboard graphs we have. I think we have about 9 in total right now. So just looking at this, we can sort of see the overall health of the service, the response times, sort of like the health of Postgres, like is our database under load, what is our error rates, things like that. And we've gone through and started instrumenting a bunch of the application as we've been maintaining the service. And if you actually go to this URL, it's publicly available. We're trying to run this project as a community project where people can sort of check and see what we're doing and make sure to keep us honest about how we're running the service. We also have Librato also allows you to if like certain alarms go off, you can set alarms that will happen. And so like between, I guess like before 1 a.m. on February 21st, like a bunch of errors happened. And so at that time, like it would fire off a notification to PagerDuty, and one of us would get paged so we can take a look, like maybe the app server needs to be restarted, or maybe the database is under load or something, and we can take a look at it. So definitely just having monitoring all around, trying to run a real service, and treating this project pretty seriously. So in order to instrument all this stuff, we're using this metrics gem, and it has reporters for Librato. So essentially you just sign up for Librato accounts, you get a user and a token, and then you can go and just set it up inside of your app. And so in production, we have a Librato reporter, and then you want to make sure in development, so we just send all our stuff to DevNull for local development. So when we're actually looking at the logs locally, we don't get a bunch of Librato metrics that get printed out. They can get really noisy really quickly. And then you can do things, what's nice about metrics is you can have timers and other things, or histograms, and easily generate and instrument parts of your app. So this is pulled directly from our source code. So we have a dependency timer, which is one of the graphs here. We just get the timing information, how long it takes to process this piece of the code, and then it sends it off to Librato, and you can do a lot of really cool graphs here. So for help that we're looking for, if you're interested in helping out, is well, we would like to compile a list of like Bundler and community usage metrics. So I guess on the client side, like now that we control both the server and client side, within Bundler we can start tracking like potentially like have a unique ID for each like session that someone does, and pass that along to the API, and then you can see like, well, generally like what is the average size of people's gem files, including like all the dependency information, like how big is the payload that people are fetching? Because currently, since it's stateless, like we only see like for each call like what it is, and we can't sort of correlate that information. So that requires doing stuff within Bundler, and then also on the Bundler API, as well as like inside the webhooks. We also need to implement yank stuff. Like right now, it only does stuff for adding gems, but like when you remove a gem, we should also get notified for that. So I think rubygems doesn't even have webhooks for that. And then also any people who do operations monitoring, helping us improve that process to make it better would be really helpful. So just really quickly, are there any questions at this point? Yes?
Just out of curiosity, how often are you actually polling rubygems?
When we initially did it, I was polling basically every minute. But since it was like, it's on S3, so they're static files, so it's not like a huge load. I think now it's like once every 30 minutes or something, because we have the webhooks in place. So it's not needed as much. Yes? Oh, for caching it on the client side? There's definitely stuff we're talking about for that. James Tucker, who is part of the RubyGems the RubyGem client team, is working on, I guess, a new format index that hopefully will allow us to do potentially incremental updates and not have to actually have all this infrastructure in place for Bundler. So, like, you're talking about static files, like super fast, don't need to do SQL calls, doesn't have to be dynamic, and then you could easily cache that data.
If you're a light client side synchronized like that would be fantastic. It's still really slow, and I think we maybe in local mirror, in Australia, it's still annoyingly slow.
Gotcha.
I'm no disrespect, but
no.
I spent a lot of my life in Bundler.
I'm totally sorry.
I'm going to go get a coffee 4 or 5 times a day, it seems. And I'm sure that's true of a lot of people here, so it'd be great to see what we can do to fix that.
Yeah, no, I mean, people have ideas for that. Totally open. I mean, this is a community project. It's not our project. It's not a private thing. We try to open up as much as possible. Like, we make the Librado graphs public so people can look at them and see how we're doing. Like, I was talking to the Librado guys, and they were even talking about potentially just putting it on the Librado page. I mean, all the code is open source. I mean, if people want to help out, like, totally open to having help. Yes?
So with your webhooks, how are you actually handling that on RubyGems side? So how are you, like, it's off the deep or something that's getting run?
So when you push So this code actually lives in rubygems.org if you go to the rubygems.org Rails app. So when you do a gem push to rubygems, it runs code on the Rails app. And one of the things it does is it like rebuilds the indexes, and like, so it does a bunch of stuff in order to make a gem be completely pushed. And so we got this method added, so it actually just calls this thing as well. So now it just calls the API endpoints and then passes the information from that gem to our endpoint.
I was actually referring to, you said that RubyGems actually allows people to register webhooks as well.
Yes.
So like, how does that get handled by the service?
Oh, by Bundler API? Or do you mean just like RubyGems in general? So yeah, so it's similar to this in the sense, so like there's they store it in their database, and essentially it's just like they have if you look at the RubyGems code, there's a thing called like calling webhooks or something, and essentially just goes through all the webhooks and it checks like, does this apply to this gem? And if it does, then it'll make a network call to whatever endpoint is specified. If you have more questions, and I can like totally show you where it is in the RubyGems code. So.
Just thinking aloud, but
Yep.
So, do you think it actually makes sense maintaining your own gem server or having, is there a thought process where you can have rubygems itself to distribute that one?
So I know there's been talk about distributed rubygems stuff. Like I know Python does it really well. Like I think Cheese Shop is the equivalent in Python. And they had to do distributed mirroring really well early on because cheese, like, it goes down constantly. So like luckily for us, like rubygems.org has actually really good uptime. And so, but no one even notices when that stuff goes down because you're probably just using some other mirror. And definitely, like, there was some work on the rubygems mirroring project to be able to like mirror like everything on rubygems, but I'm not sure what the state of that is. I know James was working on it, but I think he hasn't worked on it recently. But yeah, I mean, if people want to help out with that, like, I know people are open to it.
Does having gems coming from GitHub affect the performance of the resolution process? Or the frequency which it has to do a full resolution again?
Not, I mean, it's not like it has to do a bunch more work. Like you have, it's considered like a different gem source. So you have to like make calls back to the bundler to like rubygems.org usually to make sure there are no other dependencies, but it's not like a huge like hit. No other questions? I guess there's only 5 minutes left. I don't know if I should go into my bonus round. Speed round? Okay. I guess bonus round. Yeah, feel free to cut me off whenever I'm over time. So I've been working on this cool project called Bundler API Replay. And the whole purpose behind this project is since Bundler API is stateless and we're running it on Heroku, we get like some cool things. And so the code lives here. It's under my GitHub. And then just Bundler API Replay. And so if you ever used Heroku before, there's this concept called Heroku log drains, and it allows you. So traditionally, you send like all of your logs to some UDP syslog server, and so you can sort of store all the logs that you're getting from Heroku. You can add a syslog drain, and so in Heroku logs you get like the router logs, you get your app logs, all this stuff like aggregated together. And what's most interesting is you get all these router logs here. And so, so we get like the path information, you get the host and all this stuff. And so we actually get like all the requests that come to your app. And given that, you can actually like keep track of this information and send it to some other app, right? Like you can essentially stage a bunch of other Bundler API apps and send this traffic, like essentially this data to it, and then you should be able to get the same exact output back, right? As long as rubygems has not changed, like the local cache, right? It's a completely stateless thing. There's no session information, there's nothing. And so that got me thinking of like how we can build this to essentially construct a bunch of other things to be able to test stuff in production using production traffic. Like Richard was talking about in his presentation earlier, like having real dev data, like or real production data is really helpful, and not just having stuff in a simulated environment. So on Heroku, we have this we have this labs feature called HTTP drains. So it allows us, instead of using UDP, we can send the logs over HTTP. And so if you enable this lab feature and then you do drains add, you can, instead of passing a syslog server, you can now add any like HTTP endpoint. Doesn't even have to be on Heroku, it can be anywhere. And then you probably just want to have use like basic auth to make sure people can't send like garbage logs to you. And so we can build a really simple Sinatra app here that takes that request body, checks whether, and in our case, I'm only interested in the router logs, check if it's a router log, and if it isn't, like go through and like start sending traffic somewhere. And so as an experiment, so originally we were running on Ruby 193. We had 6 dynos on Thin, and like I was pretty interested in JRuby. We just launched JRuby support. Been talking to Charlie a bunch and seeing his presentations all last year, and really just want to get a concept of like what is JRuby performance in the real world outside of like the benchmarks that people have in their presentations. And so we're just running like a single dyno running Trinidad. And so trying to just like get like parity between production and our staging environment. There's this concept on Heroku where you can have these follower databases. And so you just do Heroku add-ons, add some follower. So in our case, we essentially, so before I was talking about how we had that Ika database. And so I created another Ika database that was a follower of production. And so it had the same data and the same resource, the same CPU, the same memory, stuff like that. And then, so you can see a list of our databases. And then, so if we connect that to our JRuby app, we can get like a fairly fair comparison. So this is just a quick, like, sort of graph of what we got. And as you can see, like so I think the green is the JRuby graph for dependencies at the 1 minute rate, and the orange is the one for thin. You see it like it follows it along pretty quickly. And actually, like the 95th percentile for JRuby is lower than what it is for MRI, which is pretty impressive because it's running on a single dyno on Trinidad, which is a gem HTTP web server using Tomcat. And so like you get some pretty impressive performance numbers, and like you can measure this over the span of a really long time without having to affect production at all, which is really interesting. So we've been doing some pretty interesting stuff, and we did this against like various unicorn setups to get the one that we're using in production now. But there's definitely a few limitations. Like there's a lag time between obviously when the request goes to production and when it actually hits our app. So like the graphs don't match up exactly. Oops, sorry. And then you obviously can only go as fast as production at this point. That's definitely one of the problems. Instead of putting something in front of our production app, yeah, I can cut it. Yeah, if you're curious about this, feel free to come talk to me about it after. Thanks, guys.